Assalamualaikum warahmatullahi wabarakatuh. My name is Naziha Afifah binti Muhammad Noor, a final year student in Bachelor of Science, Honours Chemistry with Management. I will be presenting my final year project titled Synthesis, Characterization and DFT Studies of Monosubstituted Thiourea Ligand using Ammonium Thiocyanate and its copper and nickel complexes as antibacterial agent. I am supervised by Prof. Dr. Karimah Kasim. So here is the overview of my presentation. Before conducting this research, I did some background study for Thiourea ligand. Thiourea ligand consists of carbon, sulfur, and nitrogen atom. Is synthesized from thiocyanate and amino group under reflux, which resulting in a white crystalline solid. Compounds that contain carbonyl and thiocarbonyl group occupy an important position among organic region as potential donor ligand for transition metals ion. Thiourea coordination compound have excellent biological application which make it valuable in medicine, agriculture, coordination and analytical chemistry. So the problem statement for this research is firstly public health challenge, which is bacterial resistance, categorizing it as a major public health concern. Next is emergence of thiourea derivatives that exhibit abundance of biological activities. And last but not least, criteria for ligand and metal ion selection for optimal effectiveness. Here is the objective of my research. The literature review that I did for this research containing synthesized method and characterized method. Ahmad and his team did a polycondensation of thiourea and formaldehyde in acidic medium as his synthesized method for thiourea ligand. And next is the comparison between ligand and their metal complexes using FTIR spectroscopy. And here is the NMR spectrum table. Is from article written by Mishra and her team. And lastly, this is the result of antibacterial study that was done by Ahmed and his team. The methodology that I use for synthesize for both ligand is adapted from article written by Limben involving this following step. Firstly, combination of starting material with ammonium thiocyanate in acetone solvent. And next, this mixture are heated under reflux for 1 hour, followed by cooling into room temperature. And then addition of aniline into the mixture for another reflux period, 1 hour. And lastly, pour the completed reaction mixture into cold water, causing the precipitation of thiourea product, and filter and oven the product overnight. And here is the proposed structure for ligand 1 and ligand 2. Moving on to the synthesis method for metal complexes, I use one-pot method where the starting compound combined with ammonium thiocyanate was stirred for 2 hours, then addition of 3-nitroaniline and continuous stirring for 2 hours. And next, introducing the resulting mixture with metal compound and reflux the mixture for 4 hours. Lastly, filter and oven the product after adding cold water. So these are the proposed structure for metal complexes ligand 1 and ligand 2. These are the characterization that I use for my thiourea ligand and metal complexes, and the antibacterial study for my research is via this diffusion method. The result that was tabulated contained percent yield that I obtained and the color of the product that I observed. The yield that I obtained ranged between the lowest 57.95%, which is nickel ligand 2, and the highest 89.50% for ligand 1, which show that all the product obtained is in acceptable range of percent yield. Moving on is the tabulated elemental analysis data with the melting point. The high range of melting point tells us that the product I obtained may have some contaminate which disrupt the crystal structure of the compound. For my comparison of ligand 1 and their metal complexes, which is copper and nickel in infrared spectra, I can conclude that the notable shift and decrease in band intensity at C double bond O and C double bond S frequencies is due to the decrease in electron density and its involvement in the coordination process. This conclusion is also supported by article written by Alsus Jom'a Mirza in 2018. Proceed to my observation on NMR spectra. For nickel ligand 1 and ligand 1, metal binding of nickel to ligand 1 causes the downfield shielding of ligands. This is due to the impact of electronegativity. Similar to the article that was written by Mishra and her team, the shielding of hydrogen makes the shift of chemical signal toward the downfield region. In this slide is about application on antibacterial study for ligand 1 and nickel ligand 1 for comparison. We can note the additional oxygen donor system in the structure allow them to effectively disrupt the bacteria activity, which is why ligand 1 has larger inhibition zone in SRS bacterial plate. Some interesting note that was taken by Wanjari's article, gram-positive bacteria have a single cell membrane, while gram-negative bacteria typically has at least two membranes. However, the single cell membrane gram-positive bacteria is thicker than gram-negative membrane, which make the disrupting single membrane process become harder for antimicrobial activity. However, once the membrane is penetrated, the antimicrobial activity becomes a smooth process. The last characterization of both ligand is a density functional analysis study, which helped me to describe the chemical reactivity for ligand 1 and ligand 2 using the frontier molecular orbital HOMO and LUMO. The lower the energy gap between HOMO and LUMO, high polarizability, lower stability, and increase the reactivity of this compound, which make it easier to form metal complexes. This compound with low hardness and softness is likely to have minimal toxicity and a quick-acting drug properties, which suggests us with a promising potential antibacterial inhibition activity. In my attempt to produce copper ligand 2, the yield obtained was disappointingly low, which is only 11.003%. As we know, the yield is a crucial parameter in assessing the success of synthesis process. Moving on to my melting point analysis, we can see that a wider range for copper ligand 2 compared to other complexes that I work on. This broader range suggests a high level of impurity in our product. And lastly, from the IR spectrum of copper ligand 2, we discovered the expected C double bond O functional group was absent. The potential reason between my unsuccessful attempt is the need for a longer reflux time to achieve a more complete reaction. And I must acknowledge the possibility of human errors such as inadequate cleanliness in my apparatus before use, which purpose to minimize potential contaminants affecting synthesis process. Here are ways so that I can improve my approach for better result. First recommendation is to extend the reaction time during synthesis. This adjustment ensures true reaction between initial components such as ligand and metal salt, but allowing more time for the reaction to progress. Another key recommendation is a shift from traditional condensation method to a more environmentally friendly approach, which is microwave synthesis. This method has several advantages. It uses less solvent, reduce contaminants, and potentially increase the yield of our new compound. Moving on to our third recommendation, which is implementing effective purification techniques, specifically recrystallization. This method involves the dissolution and controlled crystallization of the reaction mixture. Not only recrystallization contributes to removing impurities, but it also ensures a higher degree of purity in isolated compound. This increased purity which leads to more accurate and reliable experimental results. In conclusion, my study successfully synthesized two Thiourea ligand and their metal complexes. The very percentage yield suggests potential incomplete reaction in some instances. FTIR results provide a valuable insight into coordination of ligand to metal center, which help us to indicate the presence of C double bond S and C double bond O group. It supports the idea of complexation via oxygen and sulfur as a donor atom. Last but not least, antibacterial tests show promising result with ligand 1 and nickel ligand 1 exhibiting positive effect against E. coli, and ligand 1 show inhibition against SRS bacteria. That's all from me. Thank you.